So again, aloha mai kako. My name is Serena Mastery. Today we have a presentation by Kealoha titled IPIF, Advancing Invasive Species Management in Hawaii with AI cameras, camera systems. So Kealoha, you may begin whenever you're ready.
All right, all right. Let me just share my screen here. Is that working, Serena?
You're not in full view, like share.
You just have to go to presentation mode.
Okay.
There you go.
Yeah.
Oh, I gotta press OK. Is that working?
Yep.
Yep.
All right. Thanks so much, Serena. Thanks for that. And aloha, anuai, kako, ameke aloha. My name is Kealohanuiopuna Kinney, and I'm a research ecologist at the USDA Institute of Pacific Island Forestry. And we're giving a talk today on a wildlife monitoring platform that has a focus on Puaʻa, on wild pigs, and developed by managers, by hunters, with a emphasis on and scientists to help advance invasive species management in Hawaii. We we chose the title for this platform that we're developing, and title of this talk, Aipu'a. It's kind of like a little bit of a word play, kind of a kauna thing instead of a Hawaiian thing, but I as in eat. So we need to eat more pu'a. It's totally overpopulated and we need to do more for that. I also like the way it sounds, like we need to keep an eye on these things, better eye on them. And then of course, I as in Aina, um, the land that provides, but also Aina intelligence. And then lastly is, of course, is artificial intelligence and how we're using artificial intelligence to support camera trap analysis systems. I want to acknowledge incredible team of folks that helped to develop this platform, including Peter Van Luteren of EcoAssist, Derek and Melissa, Chris, and, Sarah, and all these folks that have really helped to, take on everything from coding to translation, to, putting cameras out, helping us annotate our data. I want to say a special thanks to Flint Hughes and the Rod Squad. A lot of this work really emerged out of our Rapid HETF BIL project, which has a focus on understanding the behavior of wild pigs and how they may be spreading rapid HETF and impacting trees. I also want to acknowledge the Nature Conservancy, who's been an incredible partner, and especially in helping to pilot some of our beta testing of these models. And with that, here's just an outline. I'm going to kind of give a real general overview of some of the issues that we face as conservationists in dealing with wild pigs. I'm going to also talk a little bit about AI wildlife platforms that are out there, our work in developing a Hawaii fauna specific platform for Hawaii. And of course, AI Puaʻa. I'm trying to classify population traits of wild pigs in Hawaii, their colors, their size, their sex, so we can have better information about the structure of these populations, and how they change. And then, of course, applications, many different ways you can use this platform to address issues that you're facing. Just a basic review about pigs in general. We know they're really good at damaging native plants. They cause soil erosion. They're great at creating mosquito habitat. They spread invasive species. And we're facing a huge overpopulation of pigs. It seems like they're everywhere. I don't think there's any place where that's really been untouched by pigs. It touches like every part of our lives, from deep in the forest to our backyards, and it's a real issue um, that we need solutions for. And then, of course, wild pigs can vector disease, both zoonotic disease and pathogens. Um, you know, the prevailing way of dealing with pigs, is for conservation, is building fences. Of course, problem is we can't fence everywhere. And when we put up fences, they're super expensive. Like right now, it's going for about $150,000 per mile of fence. It's just an extraordinary prices to put up ungulate-proof fences, and it's super hard work. It takes a lot. So that's one thing to help keep them out. But even when you put in a fence, you still have to remove animals, right? And so there are different ways to remove them, from box traps to pig brigs, snares, hunting. It's an incredible cost that goes into it. And one of the costs that's often not factored in is the long-term maintenance of fences. What it takes to monitor the fence, to deal with areas that become leaky, a tree falls on them, for example, or erosion, or a big storm event. Any of these things can impact a protected area. And we need tools to know when these things happen, and the animals that may be getting into our areas. And monitoring tools that, also, not only provide early warning, but also allow managers to rapidly respond, and also to think strategically. And some of those tools are camera traps. But camera traps they take a lot of energy, because they collect a lot of data. And so how do you deal with all the data, so need tools that are kind of automated, because the life of a manager, they have a lot of stuff to do and they can't be sitting in front of a computer all day, right? We need monitoring tools that are also low cost, right? Because everybody's dealing with budgets. They need to be easy to use, accessible, and accurate. And so one of the things our lab looked into early on was, okay, what kind of tools are out there, that are available, that people can use? And there are a number of platforms that are available. But many of these platforms require you to be online. They require you to have subscriptions. Some of them require you to know some coding, and not every management unit or managers that are out there have all of those skills or time to be able to do that. The kind of trap analysis system that we were looking for really had these qualities. Wanted to be open source. It absolutely needs to be user friendly. Something that can be offline, because a lot of places where a lot of folks work in protected areas, they're remote. There is no internet out there. It needs to have video support, integration, a way to automate and analyze the data. And then a really important piece is like having a human in the loop. It's just like ChatGPT. You can't believe everything that comes out of that. And AI supported analyses and so forth is the same thing. Humans still need to be in the loop, and it's really part of the cycle of like training and educating your model. Needs to be able to run on Windows or Apples, and of course the post-processing needs to be useful and relevant. And then the platform that really stood out to us was EcoAssist. They have a number of projects that they have been involved in over time, working in creating place-based camera trap species recognition models. New Zealand, for wolves, in France, carrion in Namibia, just a whole number of different recognition models that are really built for specific places. And I think that's super important because for those of you who have used some of these online platforms or mega detector and so forth, they're really drawing from global data sets that may not be fully representative of the things that you're looking for in your place. And right now, Hawaii does not have a Hawaii specific model. And that's something that we're developing through this desktop application. It's completely open source and it's highly customizable. The newest project with EcoAssist is a joint venture between the USDA and EcoAssist, and it really consists of 3 phases. The first one is model development, data preparation. So developing a local species identification model. So what that means is getting a lot of images that are representative of the different animals in Hawaii and putting those together. And we have a consortium of folks, Derek and others, and the TNC, and so many people have contributed to that annotation library. And then the other part of phase 1 is preparing this AI submodel annotation data set, looking at these different characteristics and trying to build a library around those. The second phase is really annotating all these local images, both for the species identification model for Hawaii and also for the AI submodels. And then the final is really developing sort of the final identification, fine tuning our models. This is kind of the basic workflow, what that kind of looks like. We have these example images. We have images right now from every island and for all of the primary ungulate species that are out there, mammals primarily. We annotate them. We use that to train our models. And then we evaluate those. And then we evaluate those in part by importing unknown imagery, so new imagery into that, deploying it and processing and testing it. And this kind of keeps going around and around actually in a cycle. This is an image of or a graph of all the different species that we're looking at and a number of images that we've collected for each one. Some of these are non-local, in this case, in the initial training, but then we also have, just the local images as well. This is a graph of, I got 3 minutes. This is a graph of just showing the accuracy, and precision of our model and its ability to identify these things accurately. This is another kind of a table format of that you can look at in terms of the precision and then also its ability to recall. And that's sort of the first phase. And then like the second phase is really like getting at this classification system, which I've been putting a lot of work into, our lab has, in terms of like the different colors. It turns out and sizes and sex, and it turns out Hawaiians had their own classification system for Puaʻa. We kind of scoured a number of resources, Hawaiian resources, the dictionaries. We're still kind of looking into the new pepas as well, the capture all of the different observations and names that were attributed to different kinds of pigs. We've kind of listed those out here. And this is a spotted pig, Puaʻa pukoa. It's what it looks like. Puaʻa hiva is like the all black. This is Puaʻa huluiwi, which is kind of interesting. We have not come across this on Hawaii, but on Maui, apparently they're more often found there. There's the Puaʻa hiva kea, which is black, but also with kind of a white sock. You can see the socks there are just above the hooves. Then you have the Puaʻa kea. It's kind of these all white pigs. The kikepa, which I have not found yet. It's a pig, from what I understand, that has just one big black spot on its shoulder, kind of like a kikepa. And then there's Puaʻa maiki, and this is kind of a classification on sizes. So this is basically any small puaʻa of any color, right? So these are just the little guys here. And then there's Puaʻa ohi, which is a little bit hard for us to discriminate, because, you know, small pigs, males and females kind of look very similar. Of course, there's the Puaʻa kane, which is the adult boar, and they're pretty easy to find if they turn the right way. And then the Puaʻa wahine. So this is an image of a sow, an adult sow, and they have different characteristics. This one being the udder that we can draw into. This is, I just wanted to share the graphical interface, you know, that EcoAssist is built on. As I said, these are highly customizable. In our case, we customize it to also be in Olela, Hawaii. We make it more accessible to our Hawaiian speakers, and also celebrate this classification system that our ancestors developed. This is just kind of how it might work if you use this. You know, you find your folder, it's got your images in there, you select which animals are in your region, you process it. This could be in Hawaiian and English. I just have it in Hawaiian here. That's a simple version. This would be the advanced version, where you can kind of change sort of the different confidences and detection or classification to kind of fine tune how it's classified. This is an image of some of the outputs. You know, it'll give you kind of quickly tell you, like, what do you have in that area? In this case, I got wild boars. It'll tell you the timing of when they're out there. This is all kind of like in one click in just like a minute or two. If you use the submodel, you can see this is the same data set that we just looked at, except now it's been broken out by the different colors and different sizes that are out there. So there's quite more of a diversity. You can also look at, you know, in this case, on the bottom graph here would be Puaʻa pukoa, so that's the spotted one. Sometimes there's variation on when they are active, and that's what this is showing. Our goal is really to develop to take this and build it into a dashboard system that managers can use, that will tell them about, you know, where their hotspots are in terms of animals coming into an area, help them strategize on where they need to put their efforts in. And then, you know, there's definitely other applications to this too. This is a kind of a super complicated graph, but it's a really cool paper that came out a few years ago, looking at hunting salvage and using information about the size and sex of animals that were captured and parameterizing models, so we could get some understanding of the probability of reproduction, probability of survivorship, both natural and, you know, hunting. and start to build a model around breeding probabilities, right? And size, in this case, size matters, right? So if you're a large size pig, obviously it's more probable that you're going to be able to breed and have large litter sizes. And that's somewhat influenced by food. In this course, in this case, it's acorns. You could look at panel B. Um, but I don't know if you guys can see my cursor, but you have large pigs. This is what it would look like for, no food, some food, and a lot of food. And then you have medium, and then you have small. And so how we target animals matters. In our case, where we are trying to understand the behavior of pigs and their impact on ohia trees, size matters. And often we don't often have enough information on population structure to make decisions and to strategize. And so we hope that this tool will help us do that. We've used this tool in our work just to try to figure out how many cameras should we put out in an area and for how long, this is a little initial array of cameras that we put out across over almost half a kilometer on each side. And you could see on the left, the cumulative detection rates vary, some are like, there were a lot of pigs that were captured, some not so many, right? So how many of these things do you need to put out to kind of get an average of those? And so using this tool has been helped us to kind of try to figure out what's the best amount of cameras across our study site in our area. And that may be useful to researchers out there, but also to managers that want to put out a camera array. We also used it to do some modeling on, well, how long do you leave these things out there? If you leave it out for a short amount of time, there's a lot of variation versus you leave it out for a long time. And of course you have less variation in the absolute difference. I think my scale on the Y here is off, but they should be 0 to 1, but column I. And then lastly, I want to finish up here and just say, I think there's real opportunities to get hunters excited about using trap camera analysis and these AI supported tools that we're developing. I think it can help optimize their success. We all know that I don't think hunting is, the ultimate solution, but it's a partial one, and we should do everything we can to optimize it. So in the left-hand corner, these are cameras that Peter and EcoAssist is developing. They're real-time cameras where a lot of these operations are done in the background, and it can give you updates on your phone or email or whatever you want. And so we're hoping to get these and help distribute them to not only to our managers out here to test out, but also to our hunters. And with that, I want to give it to Chris here.
Yeah. See here. So you have to unshare. And share mine. Okay. All right. I'm hopefully my sound's coming through okay. I'll go quick, but both of us are definitely available for questions at the end. But if you missed the opportunity, feel free to reach out. Both Kealoha and I are gladly talk about this with anyone. Before I get going, I always kind of try to introduce myself in the sense of, as a manager, you're balancing a lot of things. You don't typically just work on one aspect, and so I kind of try to keep myself grounded in a couple realms. So we want to look at the bioculture perspective when we're making decisions. We want to keep things like climate and climate change in mind. You know, how is it going to look in the future? You know, if what we're doing today matters tomorrow, or if we have to be kind of ahead of those curves, and then use the best available science and try to kind of, the sweet spot is maybe in the middle of all that, right? It's a lot of pushing and pulling of ideas, but it's always good to kind of define where you want to be. And anyway, that's kind of our focus. We've been using the EcoAssist app, and we've been working closely with Kealoha and his team to try to kind of improve our uses and to try to kind of build it out. Is this sharing okay on yours? Because
I don't see it on mine.
it says I'm screen sharing, but
We can see it.
okay,
Fix it,
good.
yeah.
Yeah, okay. So basically I kind of broke it down, and there's obviously more uses for remote camera traps, and a lot of them kind of intersect and overlap, but kind of just for quick discussion, we have, kind of our early detection of ingress, right? So a lot of our camera trapping is, did something get into one of the fenced units? And that's important to know as fast as possible. We like to use cameras that have cell phone ability, where we can kind of get the notification as soon as possible. We have kind of the post-ingress assessment. So if you have a storm, you get a bunch of pigs in, and if you can't get it right away, then now you're in this kind of other phase where you're looking at kind of where they're at, what they're doing, how many there are, and you're trying to constantly strategize to deal with that. A lot of times we're wanting to track individual animals, especially when we're getting down to trying to, like, did we catch everything we thought was there? Are they actually living in this area? Are they just moving through? We have things like cats that might just be moving through. So we want to know, are they taking up residence? We are always trying new things, with rat traps and all these other things to protect our native species. And sometimes, we don't know how good they really work. And so being able to have 24-hour monitoring on things gives us a view that we would never have. But as Kealoha mentioned, just a couple of these things start to mount up really fast. It only takes a couple cameras out for a couple weeks to really create a workload that can be unbearable. And then the other thing we want to do is we're constantly trying to learn and understand what the animals are doing and why they're doing it. We don't want to be constantly trying to remove them out of the system. We'd love to use push-pull methods. We want to know what draws them to a new spot. And, we've throughout TNC, we've used this method before we close a fence. I know on Kauai, timing it when you have strawberry guava in season so that the pigs are out, so you don't trap them in and then go after them. So these push-pull methods only work when we understand the behavior of the animals. Really, everything that we do is kind of a balance, right? Of what do we need to do? What does it cost? And then what available workforce do we have? So anything that can improve our ability to do work, we always want to test it out and think about it. So under kind of the early detection, I was just going to show a couple examples. And so at one of our preserves, we have zero tolerance for pigs in a lot of our preserves, and a pig had got in through a gap on a gate. Or there was a couple of them that got in. We saw, our team saw some tracks on the road. So yeah, we throw up the cameras, early detection, we get a shot we run it through the model. We get a good look at that pig, and now that can kind of go into a database where now we've got an individual pig. Like in this case, you can see this pig has very distinct markings. So we're able to track that pig. And then once we get that pig out, we can look back at our images and be like, yes, that was the pig that got in. Yes, that's associated with that ingress. And yes, we got it out. And it also helps you kind of work through that so you don't kind of spin wheels. Yeah, and I do want to kind of make mention that there is no fence that's going to be without ingress at some point. You're married to a fenced unit. Once you fence a unit, it's a forever commitment. And so trying to integrate things like cameras, remote cameras, and data analysis on that is really critical for our teams. The faster we respond, the less money and time that we'll use, and the better the native ecosystem will fare. So kind of post ingress. So if we get something in, typically, at least with the preserves I manage, if there is a road, they tend to kind of go on the road kind of pretty quickly. Right after they get in, if we get lucky and we can catch them fast enough, they haven't found a new home in the forest, but that's not always the case. So as they start to find new areas, they'll a lot of times they'll move off of the easy to access areas, the roads and the trails. And so we're always looking for the sign. And then, so what a typical way this would look is our team would identify, and have got great team members, hunters, they're very good at reading pig signs. They'll identify an area that's ingress has happened, or a new area that we suspect something's going on. We'll deploy the cameras. We can bring them back. We can run them through EcoAssist quickly. And then that gives us information to act on. And there's a whole bunch of things that we might do once we get that information. But being able to be a streamlined, quick process is very important to our management. Because again, it's very important that we know the number of pigs. And anyone that does this kind of work could tell you that you'll sit there even with the most veteran hunter, and you can usually say if there's one pig, more than one pig, or a whole lot of pigs. But it gets really hard to go, is there 2 or is there 3 pigs? And there's all sorts of indications, but still to narrow it down to the specific number gets very difficult. However, if you have a camera there, after you've identified that spot is worth looking at, you can get that information. So if you look at the top left here, image here, you see 3 small pigs that were working in an area. So we saw the sign. We knew there was more than one. We had our camera on there. This was an ingress from a storm a couple of years back. And after a couple of days of observation, we knew there was at least the 3. We baited the area, and we got a 4th pig to come into the camera. And again, as far as energy on our team side, we were able to determine that with just a couple trips up of taking the cameras up, bringing the cameras down. And then the other thing that's really nice about EcoAssist for our team is different areas and different preserves that we work. Pigs have different ways that are different times of day that they're out active, right? And so if you look at the top right corner, this is just one of the products that spits out from the EcoAssist application that gives you what time they're feeding. And you can see it's a pretty big chunk of time for these younger pigs in this kind of it's a pretty forested area, so they don't really get too hot, so they kind of feed all day. The other really, really important thing, again, is if you've got traps out and you don't have cameras on them and you're not monitoring, then you might come, even if you set the trap the night before and came the next day, if 2 pigs are the same size, 2 pigs work an area around the trap, and 1 pig goes in, it's very hard to tell, especially if they're the same size pig, if there were 2 or 1 pig in that area. And a lot of times with traps, we bait outside the trap, so they're going to be moving around the outside. And so here's an example on the left-hand side. If you look at that, that's at like 5:45 p.m. 2 pigs come in, and there's a whole bunch of pictures of them working the area. And then when we go up the next morning, there's only 1 pig in the trap. So one of them didn't go into the trap, right? And so by having that camera data, we already know right away that we still have a pig we're looking for, rather than assuming incorrectly that maybe we got the 1 pig in that area, and so we can, change our tactics or continue focusing in that area. The other thing, like I was saying, tracking individual animals. Do they live in the area? We had on the bottom graph on the right, another thing we use with EcoAssist is it will tell you the time of year. And so we had a camera that was put out in June. And you notice if you look at the bottom, in June, there's no cat detections. That's the detections are on the left side going up, and the months are on the x-axis going across. So June, no detections of this cat. Shows up in July, and by August, and then we pulled the camera in September. And then these are just a little couple subsets, 1 from each month, but pretty much every night, there was an increase, and there's a lot of time. So now we know in that area, we have this cat that's a resident to that area, which is a very different thing to think about than maybe a cat that is moving through, because we know they'll travel the whole island, right? We know about cats that'll go all the way up the mountain on down. So this lets us know that there's a cat there, and then, decisions can be made what to do about that. We're constantly trying to protect some critical, like some very endangered species, and rats tend to be a big problem with that, and other species. And so, we're always trying new methods to kind of reduce those rat populations. And, but again, you don't know unless you can observe it, 24 hours, what exactly is happening. So just some kind of snapshots. If you look on the left side, you know, if we came the next day after this trap, we'd say, oh, maybe no rat got hit by the trap, but you see there's a mongoose walking away with it. That happens to be one of the spots these traps seem to work really well. And then on the picture on the right, where you see a little mouse sitting on top, I've got 1,000 pictures of a mice sitting on top of that trap. For some reason, that area, they don't work very good. So rather than continuing to just keep the same trap in the same location, not working, now I can change up. I can go, well, on the area on the left-hand side, let's keep that trap there. It's working. On the one on the right-hand side, I can try a different method. So being able to quickly get that feedback allows us to be adaptive in our management, which is critical as we deal with some of these problems. The other thing, like I said, is as we're trying to think about these push-pull methods, you know, we don't want to have to try to like remove all these things. If we can just keep them from coming in. Also, if we can understand what they're targeting, why they're targeting it, maybe we do really small fences around key species, or maybe we got to do big fences. We don't know all this until we really understand those interactions and be able to observe. And what we have here is we have a endangered cyanea, and it took about 3 years of fruiting, but then the Kalige pheasants eventually found it. And in this, I don't know if the video played, but if not, you can see the still frame. They're actually eating the seeds green. So even if they could distribute the seeds, they're eating them green. They're not even getting ripe. So now we've got to think about, do we do a fence around that area? How do we keep those birds off? Where 3 years ago, that wasn't even a problem for us. We had cameras this whole time on there. So it's a new thing that started happening in an area where if we didn't have the cameras, it would be very hard to know that information. So that allows us, again, this year to be very adaptive in our management. If you look at this next one, you can see a Japanese wide-eyed. I'd call this a neutral interaction. I don't know if they're pollinating, if they're filling a niche that wasn't there, but it's always good to know they're there. And then we'll just skip this slide for time. Then you look right here, we have an amakihi, which is kind of a gold standard. Here we have a native reintroduced species with an interaction with a native species in the area. And that's really kind of a gold standard for us. You know, I think we'd only elevate one more level if we can get kind of the biocultural use back into the system. But we're really excited when we see this kind of interaction. So also, as a little side note, not really for the science of it, but as a team, when you get to observe some of these things where you're seeing success that you might not otherwise observe, it's also a big morale boost. So having that ability to just know what's going on when you're not around is massive. And with that, we'll pass to questions. And obviously, Kealoha and I, we're in the same room, so you can ask specific questions to anyone, I think, right?
Yeah. Should I turn on my thing again?
Yeah, you got to put your volume or your
My video.
Yeah, your video.
So we already have a couple questions in the chat. I don't know if you want me to read them or if you want to read them yourselves. It's up to you.
Okay.
You know, maybe before we start the questions, I just want to say that you know, it's really great working with Chris here, because it really is just an amazing relationship where you have research and development, and then you have like on the ground management. Chris has needs, we're responding to those needs, and I think that's the way it should work, you know. And you know, I want to extend that invitation out to other managers that are out there, or other folks that are dealing with similar issues and want to get involved and use this platform. And yeah, with that, we'll take any questions you have.
Yeah, so some of them are comments that are just, I can pull it up on this one. So oh, Nick, hey. It says early color names were given by David Malo in the mid 1800s. Kikepa could be Hampshire breed. Yeah. Anne said we have Puʻula, Eevee, and Lower Puna. Cool. Lisa asked, sorry if I missed this, but does your software only work with EcoAssist cameras or any trail camera?
Any camera.
Yeah, and we use them with several different cameras, and we're actually testing some of the different cameras. And I will say that, at least on our end, we've used them with some of the less expensive cameras that are a little more grainy, and it seems to do a pretty good job even without like a really crisp photo, which is kind of important for us.
Yeah. I think that's the way Peter Van Lutheren kind of designed this whole platform was really based around equity and really serving people in underdeveloped countries. So to be able to use, pretty much whatever you have to start capturing information on animal populations.
And then here's another one for you, Kealoha. So Jane asked, does EcoAssist currently ID different individuals? So it's a multi-part question. Or does the human looking at the photo do that? And then a third is, could EcoAssist be linked to other programs like Hotspotter or similar to use AI to ID track individuals?
Yeah, I'm not familiar with Hotspotter, but potentially if there are discriminating markings on an individual, you could track that individual. It just requires you to kind of build a library around them, a library of images, and that are representative of all the ways that that individual might look. And then you can train the model to look for that specific thing. Like one thing I didn't talk about is, in terms of our sizing is we're using a kind of a reference card that we're going to be putting out. And basically we're just training the AI to look for the reference card. And when it finds the reference card and knows, then we know how big that is in any part of the image, and we can scale the image so that we know we can actually measure the size of the pigs in terms of their length and how tall they are. So yes, you can train ecosystem. You can train to look for individuals or things.
Yeah, and a lot of what we're doing right now in in using the model is we'll run it, and then like the fine, like this pig is slightly different than that pig. That's still done with the human eye, but the nice thing is EcoAssist categorizes and throws it in folders, and we go through them, and it's a pretty quick process. But yeah, I think the goal would eventually be as much as you can get to individual. Lisa says, are you interested in more training photos? Because in addition to gazillions, yes, that's a feeling we've had before too, of uncategorized photos, we have thousands of labeled photos of pigs, rats, cats, birds from Kauai.
Yes, absolutely. Yeah. We'd love to work with you on that. And also speaking to, I think Emma wrote something here on a tutorial, step-by-step guide. EcoAssist, the platform, you can go to it right now, and there are a whole bunch of models for different parts of the world, for different kinds of tasks that are out there. A lot of them include models for pigs of those specific areas. But we're still kind of in this pilot development phase. We're getting very close. I would say maybe by the end of the year, early next year, we'll be able to kind of release this on the EcoAssist website. And at that time, we are going to offer workshops. There will be a kind of how to get this on your computer, how to use it. Emma, I really like where you're going with your questions. It's something that our lab is kind of moving towards now in terms of cooperative extension. So actually providing services where we can come out and kind of give you an idea. Well, okay, this is what you have. This is what an array might look like. This is how much it might cost. These are the places that, would be really good to put these things up. So you can kind of strategically look at what the needs are for your reserve managers.
Yeah, and I would just add that I think it would be, kind of to your comment there, Emma, I think it'd be awesome to see this kind of as like an extension type approach, because I know the preserves, at least that I have, intimate knowledge of, just being able to sit and talk it through with someone where you say, oh, we got choke pigs over here, we got almost none over here, and then to have someone to bounce those ideas about, like, yeah, you don't have to do the same array in both places, would be really critical, because everyone's so overwhelmed. I think a lot of times just where to start becomes hard. But I will just advocate too that once this gets up and going, we started out with just a couple cameras with one ingress thing and just started playing around with it in that way. And it does once you get it downloaded and stuff, it is pretty user friendly to move through that system. But yeah, and we would be more than willing as well to assist in that if it goes to that next phase of like, you know, hey, this is how we've used it, and to be able to share what we've learned. And then lastly, we are currently testing 2 different cameras that have a kind of a big cost difference between them. But I don't think it would be hard to just, you know, get the community together, and maybe we get 4 or 5 different cameras that are the most available ones, and see if you do have to go with that higher dollar amount, you know, to get the best result.
Yeah, absolutely.
There's another one for you. Oh, very interesting talk. Thank you. How are your cameras powered?
A lot of them are battery powered, but they could be, you know, powered externally too. You could have them on solar. You could have them plugged in, even if that's available. It just kind of depends on what camera you go with. But most cameras that we use in the field are, you know, 8 AA batteries usually.
Yeah, for us, the big hangup's usually been the battery part of it. It surprises me. I have to think about budgeting batteries this next year because but we do have some that work on solar. And I will say the biggest difference in the couple brands that we've tested in the dollar amount seems to be the waterproof sealing on those. And we have some areas that are very wet, so we use the little more expensive ones in the wetter areas.
I think it depends on what you're looking for too, you know, like if you're focused on pigs, like we have some relatively inexpensive cameras that do really great for pigs. But if there are things that are much smaller, like maybe you're looking at rodents or something like that, you probably want something that is higher resolution. And those tend to cost a little bit more.
Okay, and then there was are the cameras resilient to weather, environment, vandalism? Vandalism's a problem for sure.
Yeah, that's a great question about the phenotypes.
I'll read it out so that those so it says, what are the benefits of splitting out the different phenotypes of pigs in the AI? If managers don't tell the program the only black pig exists in the unit and a red pig walks past the camera, will the program not ID the red pig as a pig?
Oh no, it will always ID it as a pig. So it's a submodel, right? So we want to know, are there any pigs at all? It'll tell you, right? And then you can initiate if you want to know about the different colors and the sex and the size of the pig. Those are all submodels that you can initiate to tell you more about those things. The reason I think it's important is you know, we need to know something about the structure of these populations to inform how we go about removal, how we evaluate removal. So knowing something about the size structure, which could, you know, kind of be correlated to the age structure of your population, it matters when you're thinking about that. You know, also there's this hybridization of our pigs that's happened, and it's been happening over, you know, hundreds of years maybe. But it continues to happen, and pigs, you know, anecdotally, pigs are getting bigger and they're having bigger litter sizes as a result of becoming having more domesticated blood. And so I'm being able to also kind of track the effects of that and address those issues as they come up.
Okay, so then have you tried phenotypes of cats?
Ooh, no, but you know, this is really like, you know, as I mentioned before, part of this kind of emerged out of our pig behavior work, right? So we've been very focused on the pigs, and we haven't really built out all the other animals yet. But that's, you know, after we get through this, we're thinking there's a cat model that helps us identify different phenotypes of cats that are out there. I think those it's potentially could even be, you know, you could get it down to the individual because of their markings that are on them. They could be discriminated in some cases.
And there's just another comment from Lisa. We also use color as a mark recapture method to estimate population size.
Yes, yes, yeah.
Also,
So
just being mindful of time, it is coming up on 1 p.m. So if you do have to run to another seminar, if that is okay, you can always drop like we can connect you to Kealoha and Chris if you have any further questions and need to run right now.
well, I want to just call out Derek Reich. I see him on here. Hey, Derek. Derek was super influential and had some major contributions developing the Hawaii fauna specific model. You know, he probably contributed, I don't know, hundreds of thousands of images that he's collected over the years. And yeah, I just want to call him out for his help in doing this.
Yeah, and there's just another comment by Jake that says we use EBL rechargeable AA batteries and they seem to last fairly well, but not quite as well as disposable. Still worth it for us at TKC. Yeah, we've tried those too, and rechargeable batteries for some of the cameras, especially if they don't leak. If it's one that's prone to leak, we found that for whatever reason the rechargeable batteries kind of really wreck the camera on the inside if a little water gets in. But yes. So there are rechargeable, and I do know Kealoha, your lab uses rechargeable in a lot of the battery.
Yeah, some of them, yeah.
Yeah.
Yep. Oh, awesome. You know, again, I just want to you know, extend the invitation. I think my email is in the invite or somewhere. I don't know where it is, but just reach out to us or to Sarah Knox, who also is super important to our lab, or Grace Trednick, also in our lab. You know, we want to collaborate, we want to help and assist you in the work that you do, and hopefully this platform can be useful and relevant to the work that you're doing. Thanks, Nick Barca, for the David Malo reference. I want to mahalo you for that. And hey,
yeah, and I guess I'll do one more plug just from the management perspective is, you know, sometimes it can feel a little intimidating, especially doing something new. You just have such limited time, but I've done a lot of camera work since working with TNC, and this has drastically improved our ability to respond. So it was worth a little bit of investment of time and energy for us, for sure.
Yeah, I want to, you know, also call out Nick Barca there. He's been raising some really important questions, and they're questions that we're also hearing from other managers. Like, is there any number of pigs that's, you know, okay to have, you know? And I think it's possible, but it, you know, at the end of the day, we need to be able to monitor, you know, either through salvage and or camera monitoring, you know, to be able to keep track of these populations and manage them sustainably. It may be a real option in places that are, you know, highly degraded, and, you know, trying to create a win-win for our hunters and conservation. You know? So I really appreciate you, Nick, and all the work that you're doing.
Thanks for the kind words.
Hey, Nick.
Is this a open source? Like, is this something that one could contribute photos to if I just had like game camera photos from a hunting unit? And would I have access to data from other places?
Yes. It's completely open source, and the Hawaii Fauna Library is accessible to anybody. And so yeah, you could probably take that library and, I don't know, if you're just super savvy, create another AI system or something, you know. But we're gonna make it available for everybody. You know, all of this AI supported analysis is just like exploding. So we're not gonna lock that down in any way. We want to make sure that It can be used in ways that it can help conservation, help our managers.
Yeah, and the vision is being that it's locally trained to, you know, Nick, I know you guys are sitting on a lot of data too, like those could all be integrated. I mean, I don't know how many more rounds there are, Kealoha, to have to answer that, but if you really wanted to try to get those integrated into the model, definitely reach out, because it might be something that could just be plugged into the beta model that exists right now. On, I think there's one more run maybe on building it or whatever. Yeah. But yeah, just we can chat, Nick. We can discuss getting that data in there. I'd highly encourage it, because a lot of the data for the model came from some of the preserves, and so that I work, and so they're really trained in on those areas. It improves for sure.
Tell you, one of the things I really like about this platform, because it's open source, once you get it onto your computer, it's a complete package. You're not, so in other words, like, you know, sometimes you get a program, and then if that program is dependent on something else and that thing has an update, your program won't work anymore. I don't know if anybody's experienced that before. Well, in this case, once you have it downloaded, and it's a complete package, it's not dependent on anything else. And you know, if it's something that's working for you, you can just like ride that all the way through. You know, you don't even have to update it or anything like that. So anyways, I think that's a benefit. And of course, you know, you don't have to be online, you know, when that's difficult for some of us working remotely.
Amazing presentation and amazing questions so far. Does anyone else have any other questions? I just want to be mindful of people's time. It is 1 p.m. right now.
After this, we can be known as Kinzadi. I was just throw a joke in there. Thank you. I want to thank everybody for coming, and yeah, mahalo.
Yeah, mahalo.
Perfect. Mahalo. Mahalo Kealoha, Chris. We do have our next HETF webinar. Our November webinar is on the 13th with Zoe. And she's going to be talking about biocultural restoration through agroforestry in Hawaii.